So we're moving on to section 1.3, which is distance and midpoint formulas. But before we get into midpoint, you actually have to know what a midpoint is, and you have to know what a segment bisector is. So I'll pull up a picture for you, and you can copy that down. Alright, so if you look at the definition of a midpoint, the midpoint of a segment is the point that divides the segment into two congruent segments. So if I said that M is the midpoint of AB, so if they gave you M, you would know that this section here and this section here would be congruent. And now those little dash marks right there will tell us that. So if you have something, I probably should use a different color so you actually see it, a little dash mark like that. You won't see them that big, but I'm just doing that to show you an example. And then a segment bisector is exactly what is it? Exactly what it says. It basically cuts the segment in half. But it can actually be a point, it can be a ray, it can be a line, it can be a line segment, or a plane. And all it does is it intersects basically a segment. So if this line cuts through this line right here, or this DC segment, or this M, basically would cut AB in half. So this would be congruent to this. Now you know what a midpoint is, so let's introduce the midpoint formula. And you might say, well, why do I need to know a formula if I can just count boxes? Well, I'll give you an example, but before I do that, I'm going to actually give you the formula. So it's x sub 1 plus x sub 2 over 2 y sub 2 plus, y sub 1 plus y sub 2 over 2. So that's the formula. Definitely memorize that. Pause the video. Put this into your notes. This is super important. So let's say we have a point 9, 1, and then I have a point, and then I have 1, 1, negative 4. So if I want to find the distance between those two things, well, you could take a graph. Let's go ahead and plot those so you see what I'm talking about. Let's plot those. Let's go 9, 1, which would be right here, and then 1, negative 4, which would be down here. Let's change the color so you can actually see it, and then 1, negative 4 would be right here. So I want to find the distance from here to here. Well, you can't count. I can't just go, alright, this is 1, 2, 3, 4, like you would, like we did in the previous class. You have to use your distance formula. So it's basically, you want to take your averages, so this was 9, 1. So I want to find the distance between these 2 points. You have to use the distance formula. So if you think about it, I want to take the average. Since I want to find the middle is really the average. So if I want to find the average of two things, you can really take each point, or your x value, and your other x value, and you just add them together. Doesn't matter what order you go in. 9 could go first if you wanted to. And then we want to find the average, so I have to cut it in half. Same thing with the y values. Take the negative 4 and add it to the 1. So this would be negative 4 plus 1. Find the average, cut it in half to get 2. So if you have 1 plus 9 is 10, and then 10 divided by 2 would be 5. So that's your x value of the midpoint. And then negative 4 plus 1 is negative 3. So that would be negative 3 up top, negative 3 over 2. So that would be your other point. So if you look at it, if we check that out, 5 and negative 3 over 2 is really negative 1.5. So if you notice, that does fall right in to that spot right there. That's my midpoint. So that's the midpoint of the point 9, 1 and 1, negative 4. So remember, you have to use that formula, x2 plus x1 over 2, and then y2 plus y sub 1 over 2. Use that all the time, you'll always get the midpoint. Now let's take a look at the next thing, which is the distance formula. Distance formula. Now let's say if I wanted to do the same thing, I'm going to use those same points, and let's say if I wanted to find the distance between 9, 1 and 1, -4. So what you have to use is you have to use this formula. This is the distance formula right here. So this is super, super important. And let's call this A. We'll call this B. So if I want to find the distance of those, AB would equal x squared, not x squared, excuse me, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So definitely copy that down. This is very important. Put this into your notes. This formula right here will take you a long way. So this is x sub 2 minus x sub 1 squared, y sub 2 minus y sub 1 squared. Now think about this for a minute. Where have you seen these values before? Where have you seen this before? And if you set the slope formula, then you're absolutely correct, because if you think about it, we all know that this is the rise and this is the run. Alright, so that's derived, this distance formula is derived from that. So instead of thinking of it as AB equals the square root of x squared, I keep saying x squared, it's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Instead of saying that, you can really, if this helps you to remember it, and this is sometimes how I remember it, because this is definitely ingrained in my head. So you might want to look at it as run squared plus rise squared. Alright, so let's say we want to find the distance between A and B. Now you could take a ruler out and you could measure it, but you're not always going to have a ruler to use. So you want to use these formulas because most of the time they probably won't even put it on the graph. They're just going to tell you that the point A is 9, 1, and then the point B is 1, -4. So if you remember, the formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So all you have to do is fill this out. All you have to do is go through this, and it's up to you how you want to label it. I'll probably call this one x2, and I'll call this one y sub 2. I'll call this one x sub 1 and y sub 1. Totally your call. Doesn't matter to me which one you want to do it, as long as you keep it consistent. Alright, so x sub 2 we said was, what was it, 9? And then 9 minus x sub 1, which was 1. Square it. And then add it to y sub 2, which is 1. And then y sub 1, which is -4. Okay? And then we want to square that whole thing. So if you notice where these values are coming from, I'll take a step back here. This is your x sub 2, so that just goes right here. Then your x sub 1, which is down here, will go right here. And then your y sub 2, which is 1, will go right here, in that position right here, so it'll go drop down there. And then your y sub 1, which is -4, will go right here. So it's really minus, minus, a negative. When you have minus and negative, I always want to say is you add the opposite. So let's go through this, and we should have 8 squared plus 5 squared, which would be 64 plus 25. And you should see that AB is going to equal the square root of 64 plus 25 is 89. So when you take the square root of 89, you should see that AB will be 9.434 units. And make sure you label. Get in the habit of labeling. I don't know if these are miles or feet, so we have to call them unit. So after watching this video, listening to me speak about 1.3, you should know what a midpoint is, a segment bisector is. Definitely memorize the midpoint formula and the distance formula, and you should be good for this section. All right, I will see you next class. Adios.